Fine. Today's topic is melting and boiling point of D and F block elements. What is the meaning of melting and boiling points? And also the heat of atomization. The meaning of this melting and boiling point is suppose I have taken iron, it is in the solid form. At what temperature should I heat it to convert it into the gaseous state? Don't you think so? It is the boiling basically. This is known as boiling point. Heat of
Yeah,
atomization means we have to convert solid iron to atomic iron. Atomic iron means in the gaseous state. This is once again is known as boiling point. The heat of atomization is the heat required to convert solid metal to the gaseous state. Of course, it will happen after boiling only. So the question is the heat of atomization is very large. Yes, just imagine you want to boil iron. Don't you think so? It is very high temperature. Why their heat of atomization is very large? Because of the strong bond. And this bond is known as metallic bond. Now, why it is very strong? Sodium is also a metal. This is also possessing a metallic bond, but it is not so hard. It can be cut even with a knife. So the difference is all the transition elements have partly filled d subshell. Like 4s2, along with 4s2, they have 1 to 9 electron in the d subshell. So, whenever they want to make the bond, not only ns electron, but also n minus 1d electron participate in bond formation. What does it mean? Along with 4s electron, 3d electron will also participate in bond formation. Why? Because their energy is comparable. But in case of S block and P block elements, only the last shell electron participate in bond formation. But in this case, along with the last shell, penultimate shell is also participating. If someone asks you why, then you will say because their energy is comparable, means similar. That's why now 4s2 electrons are there. In 3D, if it is 1, total participation is of 3 electron. In case of scandium, once again I am going to write down here Sakti Vikram Fe Ko Ni Kyun Jana. Its configuration is 3D1, 4s2, 4s2, 3D2, 3D3, 4s2, 3D5 ये बेवफा है और 4s1 मैंगनीज 3D5, 4s2 iron 3D6, 4s2. 4s2 is common in all of these elements except दो बेवफा copper and chromium. In nickel, it is 3D8. In copper, it is 3D10. Zinc, 3D10 and 4s2. Now listen carefully. In scandium, 3 electron will participate in bond formation. In titanium, 4 electron will participate in bond formation because the configuration of titanium is 4s2, 3D2, and vanadium configuration is 4s2 3d3. In titanium, 4 electron will participate in bond formation. In vanadium, 5 electron will participate in bond formation. So larger the number of electrons participating in bond formation, stronger is the bond. So scandium, its boiling point will be the lower. Titanium has, one second.
yeah,
Okay. Larger the number of unpaired electron, stronger is the metallic bond formation, right? So if we
Yeah.
see the graph, hmm, if we see the graph, their boiling point graph is like this. Yeah, heat of atomization, like this, like this. This is scandium, this is titanium, vanadium, chromium, manganese, iron, cobalt, nickel, or zinc. See very carefully, the boiling point of heat of atomization first increases, then decreases. Why? In case of scandium, 3 electron participate in bond formation, titanium 4, vanadium 5, chromium 6, manganese is 7, and this is 6 once again. Why 6? Because the configuration of iron is 3d6 and 4s2. 3d6, the meaning of 3d6 is 1, 2, 3, 4. One orbital has paired electron. So unpaired electron are 4 in number, and 4s2 along with this is known as 6 electron. So in iron 6 electron will participate, in cobalt 5, nickel 4, and next is copper 3, and zinc has 2 only. So see the gradation. There is increase in the number of electrons participating in bond formation. Stronger is the bond, and then the bond strength decreases because the metallic bond strength decreases. In case of manganese, the highest number of electrons are participating in bond formation. But what is this? The boiling point or the heat of atomization of manganese is smaller than that of chromium. Why? Manganese should be the hardest one, but it is not the hardest one in first transition series. Why? Now listen carefully. This is the question now. Let me tell you
Mm.
once again from this. See, strong metallic bond, which is because, see, strong metallic bond, which is because not only ns electron but also n minus 1d electron participate in bond formation. Larger the number of unpaired electrons, stronger is the bonding due to overlapping of unpaired electron between different atoms, that is covalent bonding. So let me make it clear. In D block elements or transition elements, they show metallic bond as well as covalent bond. Now, this is a very special thing. They also show the covalent bonding, right? So, why heat of atomization of zinc, cadmium, and mercury is very small? Because the configuration of zinc is 3d10. All the electrons are paired. They will not participate in bond formation. Only the unpaired electron participate in bond formation, and their configuration is 3d10 4s2. So in zinc, only 2 electron will participate. The lowest number of electrons are participating in zinc. That's where their heat of atomization is very low. And cadmium is lying below it. It is also having the lesser heat of atomization. Mercury, we all know it is liquid in state. So just imagine its heat of atomization will be the lowest one, right? So next
Yeah.
is the heat of atomization of zinc, cadmium, and mercury is very low because of absence of unpaired d electron. Their covalent bonding is absent. Metallic bond is very weak because n minus 1 d electron don't participate because they are paired. If the configuration is 3d10, no unpaired electron is there, they will not participate in bond formation. That's why the metallic bond in zinc, cadmium, and mercury is very weak. Now, transition elements are hard because of strong metallic bond, and they are brittle also because of covalent bonding. What do you mean by the brittle? When they are hammered, then they are broken. From graph, it is clear. See the
Okay.
graph. Titanium,
Yeah.
vanadium, chromium, manganese, next iron, cobalt, nickel और नीचे zinc. Second transition series. ये जरीना भी मोटा करूरा पीडी करते रहते आज आज इन्हें काट दो. You see there is also dip at technetium. There is dip at rhenium. So this is the question, why manganese has lesser heat of atomization, though it is possessing the largest number of electrons. 7 electrons were participating in bond formation. Then why its metallic bond is very weak? Its answer is, from graph it is clear that with the increase in strength of the metallic bonding, melting point also increases and then decreases because metallic bond strength decreases.
Okay.
We have to read from this point. So see, from graph, it is clear metallic bond strength first increases, then decreases. But this is the question, why there is a dip at manganese. It should be at the top, but there is a dip. Means its melting point is smaller than that of chromium as well as iron. Why? Now see the answer. But there is a dip at manganese, technetium and rhenium, though they have the max number of unpaired electrons. So should have highest melting point among their groups, but their half-filled n-1d5 configuration, their electrons are tightly held to the nucleus. Now this is another problem. Because of the stable 3d5 configuration in manganese, the atom is very stable. So atom atom bond, like atom manganese 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 manganese, interatomic bonding will be very weak. No doubt, the configuration is very stable. As an atom, manganese is very stable. But interatomic bond is weaker because of stable exactly half-filled n-1d5 configuration. Their electrons are tightly held to the nucleus. So interatomic molecular forces are weak. That is, weak metallic bond is there. That's why, because electrons are not delocalized. Delocalized means they're not roaming here and there. टिके हुए हैं एक जगह पे, they are present at one place only, right? And why zinc, cadmium, mercury soft? Because only ns electron participate, because they have fully filled configuration in the d subshell, like 4d10, 3d10, and mercury has 5d10. They will not participate in bond formation. Only 2 electrons are participating. That's why their metallic bond is poor. Next question is, why the chromium is having the highest melting point? Because it is having the maximum number of unpaired electron and strong metallic bond will happen. Right? Once again, the first question is, transition elements have high heat of atomization or melting point. Answer is because they have strong metallic bond. Next, why do they possess strong metallic bond? Because not only ns electron, also n-1d electron participate. Why do they participate? Because of the comparable energy. Then why first melting point increases then decreases? Because in the beginning the number of unpaired electrons are lesser, they are going to be increased, then after midway the number of unpaired electron will decrease and the metallic bond strength decreases. Then why there is a dip at manganese, though it is having the largest number of unpaired electrons? So the answer is, as an atom, because of the stable configuration, it is very stable. But interatomic force like manganese bond is very weak. That's why there is a dip at manganese. The next question is, why in this transition series, chromium is having the highest melting point? Because of the presence of largest number of unpaired electron, its metallic bond strength will be very high. Is it clear?
Yeah.
Total 5 questions are there regarding this particular topic. So we have done, right? The next is ionization enthalpy. Let us see 5, 6 questions of ionization enthalpy also.
Okay.
Okay. Ionization enthalpy. what is the meaning of ionization enthalpy? Suppose this is the atom nucleus and these are the shells and this is the electron, right? Energy required to remove this electron from outermost shell is known as ionization energy. What is this? This is the energy required to remove the most loosely bound electron from atom is known as ionization energy. It is quite clear. If the size of atom is very small, then higher energy is required to eject it because it is very strongly or tightly bonded to the nucleus. Now, if the electron is far away from the nucleus, it means it has weaker attraction with the nucleus, so lesser energy will be required to eject it. So it is quite clear, if size is smaller, IE will be larger. And the very second thing, after losing one electron, the remaining electrons are more tightly held to the nucleus. Means after the removal of one electron, size will decrease. Now the second ionization energy, that is the energy required to remove the second electron, definitely is higher. So let us see. Their ionization energy lies between those of S and P block elements. Why? These are the S block elements and these are the P block elements. So D block elements are kept in between the S and P block elements. That's where their ionization energy will also be in between these two. The difference of ionization energy between two consecutive members is very small. What is the meaning of this line? See, once again, Sakti Vikram Fekoni Kyujana. Sakti Vikram Fekoni Kyujana. Now see, its size is bigger than smaller, once again bigger. Because yesterday I told you, because of the fully filled configuration, inter-electronic repulsion will happen and the size of zinc will increase. Well, from left to right, size is going to decrease and ionization energy should increase. But there is not regular trend. What is the meaning of not regular trend? Like its ionization energy is very, size is bigger, so IE is very low, IE more, then less, more, less, like irregular variation is there. Why there is irregular trend in first ionization energy of 3D metals from left to right? The answer is because the 4s and 3D electron or orbitals, their energy is altering, is going to change. How? Because the removal of one electron alters, means changes the relative energies of 4s and 3D orbitals. That's why. There is not
Okay.
regular trend. The regular trend should be there. Why? Because from left to right, size is going to decrease. So IE should increase regularly. But it's not regular. Why? Because the removal of electron alters the energy of 3D and 4s. Why? Because there is very small gap or difference between these two. The whole chemistry of d block element is just because of the comparable energy of ns and n minus 1d orbital. They are lying closer to each other. That's where this all problem is happening. Okay. Next is
Hmm.
manganese has very high third ionization energy. Good question. Let us see the configuration of manganese. Its atomic number is 25. Its configuration is 3d5 4s2. The question is third IE is very high. How? After the removal of two electron, it will acquire the very stable configuration. The most important and stable configuration is 3d5 and 3d10. So manganese has a stable configuration after the loss of two electron. Now we want to lose or remove third electron. Manganese will say, खबरदार मेरे इलेक्ट्रॉन को हाथ ना लगाना. क्यों ना लगाएं? I am stable now. After the loss of two electrons, I am quite stable. I will not lose my third electron. हमने कहा हम तो निकालेंगे. निकालो फिर तुम्हें बहुत एनर्जी देनी पड़ेगी, दम लगाना पड़ेगा because of the stable
Okay.
configuration, right? Now, it says iron has lesser third IE. Let us see the iron once again. So iron has 26 atomic number. The configuration is 3d6 4s2. After the loss of 2 electron, it is not so stable. It will say निकाल लो एक और कोई बात नहीं मैं इसके बाद stable हो जाऊंगा. That's why if we compare manganese and iron, if I ask you who is having the highest third IE, answer is manganese because after the loss of 2 electrons, it will acquire stable configuration. So third electron is very difficult to remove. But in case of iron, after the loss of 2 electron, it is not so stable. So it will say yes, you can take one more electron also, right? No doubt third I is very high. But if we compare manganese and iron, then manganese is having higher third IA. Is it clear?
Yeah,
Very,
kinda.
very good. So, fine. So manganese has very high third IE, but iron has smaller third IE. Why? Because manganese 2 plus has 3d5 stable configuration. So third electron is difficult to remove. But iron 2 plus has 3d6 electron, which is after losing one more electron will be stable. In comparison to manganese, iron can lose third electron easily. The higher value of third IE of copper and nickel and zinc is due to fact that they are stable in plus 2 state. This is once again very important question. One more question is there. The configuration of copper or nickel or zinc. Let us take first the example of zinc. You know the configuration of zinc is 3d10 4s2. After removing 2 electrons, it has very stable configuration. So that's why its third IE is very high once again. The third IE of zinc is also very high because after the loss of 2 electrons, it acquires stable configuration. Now in case of nickel, its configuration is 3d8 4s2. It is also having very high third IE. But we don't understand 3d8, how can it be stable? After the loss of 2 electron, neither it is 3d5 nor it is 3d10, then why it is very stable is a very important question. Let me tell you. After losing 2 electrons, nickel will become nickel 2 plus. You know it has very high hydration energy. Means water will love it. Why? It's an
Okay.
internal matter. No reason is there. Nickel 2 plus, it has very high hydration energy. That's why it says, sorry, I'm not going to give you third electron. And same is happening with copper also. Copper 2 plus is also very stable. It is 3d9. No doubt the configuration is not stable, but they have other stabilities like it has very high hydration energy. It is also having high hydration energy and 3d10 itself is very stable. Next is the first ionization energy of 5D elements is higher than those of the 3D and 4D transition element. The meaning of this question is like Sakti Vikram Fekoni Kyujana it was. Next was ये जरीना भी मोटक रूरा पीढ़ी करती रहती है. The next was ला हफ्ता उरे ओ सिरपट. You know, this is 5D series. This is
Yeah.
2D series and this is 3D series. You know, they were having the same size because of lengthenoid contraction. Just we studied right yesterday. Lengthenoid contraction.
Yeah.
So automatically this 5D series will have higher ionization energy because of the lengthenoid contraction. The outermost electron is closely held to the nucleus. That's why this is the answer lengthenoid contraction. Next is if ionization energy is small, then that oxidation state is stable. What is the meaning of this line? Let me explain you. The meaning of this line is that the question is basically K2, PT, Cl6 exists. This is the question normally being asked. But K2, Ni, Cl6 does not exist. Though platinum and nickel both belong to the same group. Then why platinum is making this compound, nickel is not making this compound is the question. In this compound, platinum shows plus 4 oxidation state and nickel also shows plus 4 oxidation state, right? So the question is platinum can lose 4 electron, but nickel is not losing 4 electron. Basically, the question or reason behind is this: K2PtCl6 exists, but K2NiCl6 does not exist. The meaning of this question is that platinum can lose 4 electrons, but nickel is not losing 4 electron. Why? The answer is whenever the ionization energy is higher, then that oxidation state will be unstable. Meaning platinum की first 4 IE1, the energy required to one electron, the energy required to the second electron, energy required to the third electron, removal of third electron, energy required to remove the fourth electron. The sum of the four ionization energies of platinum is lesser than that of nickel. Means in case of nickel, more energy is required to lose 4 electrons in comparison to platinum. So whenever lesser energy is required to lose the electron, definitely electron will be lost. So answer is platinum can show this compound formation because of the smaller sum of the first 4 ionization energy than that of nickel. On the
Okay.
contrary, next question is nickel 2 plus is more stable than platinum 2 plus. Now, in this case, the first two ionization energies ka sum for nickel is lesser than that of platinum. The meaning is that if you require the small amount of energy to remove the electron, that oxidation state will be very stable. आयरन सेज मेरे
Okay.
3 इलेक्ट्रॉन निकाल लो तो उसकी 3 प्लस स्टेबल होएगी. मैग्नीज कहता है मेरे मत निकालना, मेरे 2 निकालना खाली, तो उसकी 2 प्लस स्टेबल होएगी, है ना. वेन एवर यू
Yeah.
नीड एक्स्ट्रा एनर्जी टू रिमूव द इलेक्ट्रॉन, दैट इट मीन्स दैट ऑक्सीडेशन स्टेट विल नॉट बी स्टेबल, राइट.
Okay.
Now let us move to the questions because 2 days we have studied the theory,
Yeah.
है ना. Okay. I will send you the notes also today, right now.
Yeah. Okay.
I'm writing down the answers also. You have to learn.
Okay.
What are the D block elements in which last electron goes to D subshell of
Yeah.
penultimate shell? Penultimate shell. What are the transition elements which show transition from metallic to non-metallic behavior? But the real answer is they should possess partly failed D subshell. Next is
Yeah.
why zinc, cadmium, mercury are not transition element because they don't have partly filled subshell. What do you mean by the partly filled? D1 to 9
Like half.
electrons. Okay, not half. D1 to 9 should be there. ठीक है, not complete,
Okay.
should not be complete. Then 10 नहीं होना चाहिए. Though, although silver
Okay.
has 4d10 configuration, still it is transition element because sometimes silver shows Ag2 plus ionic state in which the electrons are 4d9. Sometimes silver shows Ag2 plus ion formation in which the configuration is 4d9. So it is partly filled.
Okay.
What is the position of D block elements in between the S and P block elements?
Yeah.
Write the configuration of chromium 2 plus 3 plus. It initially it was having 24. It is 3d5 4s1. After losing 3 electron, it will become 3d3. Copper plus 1 will become 3d10 after losing 1 electron. Cobalt 2 will become 3d7. Manganese 2 plus will become 3d5. I've also discussed this earlier.
Yeah.
Okay. Why iron is transition element but not sodium? Because sodium is not having partly filled d subshell, but iron has.
Okay.
Why scandium is transition element? It has partly filled d subshell, but zinc is not.
Okay.
Okay. Why there is small difference in size of the elements in 3D series from left to right? Because the increased nuclear charge and the screening effect counterbalance each other. Yesterday I told you, right?
Yeah.
Why zirconium and hafnium have similar sizes? Because of lanthanoid contraction.
Lanthanoid contraction.
Do you remember that point? Okay, I'm writing down here. It was ये जरीना भी मोटक रूरा पीढ़ी करती है ला हफ्ता उरेओ spirit airput. I told you yesterday, zirconium is having the number of shells 5, but hafnium was having the number of shells 6. But 4f इलेक्ट्रॉन says हट हमको नहीं चाहिए तेरा चार्ज न्यूक्लियस को बोलते हैं. तो न्यूक्लियस कहते हैं कोई नहीं तुम साइड पर जो सिक्स्थ शेल को जोर से खींचेगा अपनी तरफ और साइज छोटा हो जाता था. दिस पुअर शील्डिंग ऑफ
Oh.
न्यूक्लियस बाय 4f इलेक्ट्रॉन इज नोन एज लेंथेनॉइड कॉन्ट्रैक्शन. ठीक है.
Okay.
That's why
Okay.
their
Yeah.
size is similar. No doubt zirconium is having 5 shells, but hafnium is having 6 shells. Still, the size is similar because of the poor shielding of nucleus by the inner line 4f electron. ठीक है.
Okay.
What is lanthanoid contraction? It is the decrease in size from left to right in lanthanoid because of the poor shielding of 4f poor shielding of nucleus by the 4f electron. Right? The same answer we have to write down. Right? Next is why the elements of third transition series means this series have similar as those of the second transition series lanthanoid contraction. Indirectly want to
Yeah.
ask, zirconium and hafnium have similar size? Lanthanoid contraction. This niobium and lanthanum, these are having the same size because of this, I mean, lanthanoid contraction. Okay.
Yeah.
Next question is, I have uploaded yesterday's video also on YouTube.
Oh.
Okay. You can watch if you want to.
Okay. Am I visible in that?
Yes, beta.
Am I visible in that video?
In that video, you are visible. In this video, you are not visible.
Yeah, because I opened.
If you have problem, I can do the changes also. But
Oh,
not too much
yeah, I
visibility
can
is
do that.
there. Not too much.
Okay,
You can check
fine.
it. No problem.
Okay. I didn't see him.
हाँ कोई problem. No problem. Okay. See, why element this is done? Why transition element possess high heat of atomization? Because of the strong metallic bond. The next is why do they possess strong metallic bond? Because not only ns electron but also n minus 1d electron participate. Then why
Okay.
melting point of transition element first increases then decreases? Because initially the number of unpaired electron increases then decreases. This is done today right now, right? Why there is
Yeah.
a dip at manganese? Because as an atom, manganese is very stable because of the stable configuration, but interatomic bond is weaker. That's why there is a dip in its melting point.
क्या
Why
चीज
is zinc?
weaker है?
Yes, yes.
What's weaker in that?
Metallic bond is interatomic.
Oh, oh,
Interatomic
okay.
bond is weaker. Between metal metal
Oh,
manganese
that's fine.
manganese is not so strong because of the stable configuration. As an atom it is stable. Why
Okay.
zinc cadmium mercury are soft? Because their metallic bond is poor or weak. Metallic bond weak. Why? Because d electron do not participate, only 2 s electron participate. That's why. Why they don't participate? Because D10 configuration is there in all of these elements. Name the
Okay.
name the bonding in transition element, metallic as well as covalent. Metallic and covalent, right?
Yeah. After this chapter, what will you start?
You tell me which is to be started.
No, because like I have pre-boards like now on November around 13 or 14th. So I just wanted to ask like which chapter will you start like from then first?
How many chapters are there?